Hello everyone, today we're going to be looking at something called special right triangles. You may have heard of the Pythagorean theorem before this. It comes from the Pythagorean theorem, and special right triangles, there's two types. There's something called a 45-45 90-degree right triangle, as well as 30-60-90. In this video, we're only going to look at the 45-45 90. So right here, where does it come from? So you may have seen Pythagorean theorem to solve for the missing side lengths of a right triangle specifically. So here's our right triangle. You'll notice that if these two side lengths are the same, then these angles must be 45 and 45 degrees. And what it does is it creates a little pattern based off Pythagorean theorem. If I know these two sides are the same, x and x, so this will be x squared and x squared, and this will be y squared in our Pythagorean theorem. When we simplify that, we get 2x squared equals y squared. So if I wanted to solve for this missing length right here, what y actually equals, I'm going to take the square root of both sides. And what you're left with, instead of actually plugging into the calculator the square root of 2, I'm going to leave it as the square root of 2. But x squared, when you take that square root, just becomes x. So this length is really x square root of 2. What does that mean? I can choose any length I want for one of these legs, let's say 3 and 3. This now is 3 times the square root of 2, and that's what this is showing down here. I can take whatever the small legs are across from the 45 degrees, multiply it by the square root of 2, and that is the length of this hypotenuse. And we say this is in simplest radical form. We're not going to be using the calculator and actually taking the square roots of the values. We're going to leave them in simplest radical form. So when I look at these examples, I did 3 here in terms of leaving the numbers. If I can see that these two side lengths are the same, and it's a right triangle, I actually know that these are going to be both 45 degrees. How do I know that? Well, 180 degrees minus the 90 degrees is 90 degrees. But I have to divide it by 2 because, again, these are the same. So they're both going to be 45, creating our 45-45 90 triangle. So if this is 2 and this is 2, this is going to be 2 times the square root of 2. This one's going to be 3 times the square root of 2. This one's going to be 4 times the square root of 2. So let's say for a second, what if we don't know the legs, but we knew the hypotenuse, this long side, let's say this is a 45-45 90 triangle, and let's say I knew this hypotenuse was 5 square roots of 2. You may have guessed already that knowing that this is 5 square roots of 2, and knowing that this hypotenuse has to be something multiplied by the square root of 2, this is going to be a small leg of 5 and a small leg of 5. Let's try another. 13 square roots of 2, which means our small legs would be 13 and 13. It's pretty quick. What if, and this is, let's put a little star here, this is going to take some extra steps that we're not going to get into in this video, but I will be sharing other videos regarding this. What if I knew this length was a length of 8, and this was a 45-45 90 triangle? Well, our pattern says this has to be some number times the square root of 2, which, as you can see, it's not. It's just a whole number 8. So we would have to set this equal to our side length, x, times the square root of 2. And so to solve for this missing small side, right, because we don't know what that small length is down here, we would divide by the square root of 2 on both sides. So now it's showing that that small leg is going to be 8 over the square root of 2. This is a step, an additional step you'll see in other videos, but it's something called rationalization. I don't want you to focus on it too much right now, but you will have to rationalize this denominator, meaning we're going to do a process where we're going to eliminate that square root from the denominator, but you'll see that in other videos. Let's take a look at some examples. Before we do anything, I find it very helpful to redraw the triangle, and I'm talking about redrawing that template. You'll notice on all 3 of these examples I'm redrawing that template. And that template tells us that across from the 45 is our small legs, and then we have our hypotenuse, that small leg, times the square root of 2. So looking at this triangle, I know the length across from the 45-degree angle is a 9. So let's say this is 9. This other leg must also be a 9. So this would be 9 here. And since this length is the small leg times the square root of 2, and that's the hypotenuse, I'm going to take whatever my small leg length was and multiply it by the square root of 2. It's that quick and easy with special right triangles in a 45, 45, 90 triangle. If you know the small leg, you know the other small leg, and we know the hypotenuse, whatever that number is times the square root of 2. Let's take a look at B. This is the small leg, 2 square roots of 2, which makes the other small leg, it must also be 2 square roots of 2. Our hypotenuse is supposed to be a number times the square root of 2, and this is where it gets really confusing here. It's a number times the square root of 2, so this leg must be 2 square roots of 2, but don't forget, we still have to multiply it by the square root of 2. So often I see people just stop right there because they see the square root of 2. You still have to multiply it. We also have to simplify this example. So this is where you may want to click the links below if you're not sure, right? These two on the guided notes. That will help you with simplifying square roots, multiplying them as well. When we multiply here, we are going to take our coefficient of 2 times the coefficient of 1 to get 2. And then multiplying our square roots, square root of 2 times the square root of 2 is the square root of 4, which the square root of 4 is back to being 2 again, because what number times itself equals 4 is 2. 2 times 2. And then we're going to multiply this to get our final solution. So our final solution actually is this length is a length of 4. Let's look at the last example. What if I told you the leg length, right, not the hypotenuse, the leg length was 5 square roots of 3. So again, 45, 45, 90 triangle. My two legs are the same. So I'm going to write that in. My leg length of my 45, 45, 90 triangle is going to be 5 square roots of 3. This one would be the same. And don't forget, our hypotenuse is that leg length times the square root of 2. So 5 square roots of 3 times the square root of 2. Just like our template says. That leg length times the square root of 2. And we do have to simplify this one. We would get this to be 5 square roots of 6. And you can leave it like that. Don't use the calculator, just leave it in simplest radical form. Sometimes you will have to simplify that radical, like the square root of 8, or maybe the square root of 18. That would be another one. What about the square root of 24? That's another one you would have to simplify. But this one you do not have to simplify any further.